Mars landslides defy the laws of physics. Now scientists might know why. Some landslides on Mars seem to defy an important law of physics. Long, runout landslides are formed by huge volumes of rock and soil moving downslope, largely due to the force of gravity. But their power is hard to account for. With volumes exceeding that of the Empire State Building, they move at high speeds of up to 360 km per hour over flat surfaces for up to tens of kilometers. This seems to indicate that there is no or very little friction present. Friction is the fundamental physical force resisting the motion of one surface sliding relative to another. The lack of friction in these long landslides, compared to normal, shorter ones, is comparable to suddenly losing traction when driving a car on a wet or icy surface. You pull the brakes, but you stop well beyond where you intended. Let's go bowling. Join us on December 11th for the ultimate team outing. Yes. To explain this conundrum, scientists have suggested that these landslides must have taken place at a time when the area was covered in ice. But in our recent paper, published in Nature Communications, we have come up with another answer. The results could help us protect against harmful landslides, both on Mars and on Earth. Geologists have discussed the odd behavior of Martian landslides since they were first identified nearly half a century ago. These types of landslides have occurred on Earth in its geological history too, but because our planet is active with erosion, atmospheric weathering, wind, rain and so on, vegetation cover and plate tectonics, their evidence can be masked if not completely erased. This is the reason why we study long, runout landslides on other planets in our solar system. There are in fact a number of advantages of doing so. On the red planet, landslides and their morphological features are well preserved for millions of years because of the reduced erosion rate and absence of vegetation and plate tectonics. We now also have available satellite images of the surface of Mars with a resolution that is better than what we have for some regions here on Earth. As a result, we can conduct observations and measurements that are not so granted on our planet. New findings. Valles Marineris on Mars is a 4,000 kilometers long, straight canyon. As for more on this story, visit the news article link.